Hey everybody, my name's Michael Chow, and I'm joined with Rich Ian as we do this little tiny workshop on great tables. So just a little bit about us. We're software engineers at Posit, PBC. Collectively, we have 2 PhDs, 2 dogs, and 5 cats, and we're total fanatics about table display. So in this workshop, the way it's set up is we'll alternate between slides and a code along. So in the slides, we'll give you a basic understanding of simple great tables concepts and functions. In the code along, we'll code through some different tables so you can see how they're made and get some practice in making tables. And the workshop materials are online, so you can find them on GitHub, on Rich Ian Great Tables Mini Workshop. And if you have any questions, we have a Great Tables Discord, so we'd love to have you join. And it's super helpful when people ask questions about great tables. So the big question with display tables is, what is a display table? So essentially, Great Tables is a Python library for creating publication-ready tables. And what we mean by that is less like the table on the left, which is a raw polars data frame, and more like the table on the right, which is a formatted, styled, beautified table that you might put in a report. And the big reason is the table on the left is really useful if you're doing data analysis. You really want to know the names of your columns. You want to see all of your data. But the table on the right is really useful when you want to hand it off to someone and to publish insights and try to spur people to action. So Great Tables is all about the table on the right. All right. So I'm going to go through some really nice display tables that we found on the internet to just try to highlight some of the value of publishing tables and formatting them nicely for presentation. So here's one about a basketball team. So history does not bode well for the Hoosiers. This is about a specific team. The thing I want to emphasize here is a few pieces. We have a heading, which lets you put a title and some high-level information. We have a spanner, which groups columns together with a high-level label. We have these team logos for conveying each team really quickly. And then we can also highlight rows. So this row is the topic of this article we found it from, and it's highlighted to draw attention to the main subject. And then we also have these percentage values here. So notice percentages here are formatted nicely to just be 2 decimals for people. So this is a really good looking table, and it's a nice way to communicate information clearly. It's got a little bit of emphasis, it's got some labels, and a lot of nice pieces for presentation. All right, here's another one. So this is about a specific basketball player. So this table, some nice things about it are it has bar charts. So you can actually include small graphics in your table. It also has the rows split up. So there's some grouping behind the rows. And then the last thing is it has these footnotes here for providing additional details. All right, and the last table to show you is this table that's CO2 intensity and power consumption by country. So notice this has countries ordered by their CO2 intensity, and then it has them the percentage of different power sources that they consume. And notice the use of color here, that this table is able to code more green sources of power against dirtier sources of power here. And we're able to see through this heat map, trends that countries that tend to have low CO2 intensity tend to use cleaner sources. So this is a really neat way that tables can provide sort of heat map information to people. We have nicely formatted percentage values, and then a heat map here to make it easier to pull out patterns. All right. So these 3 tables are made from code, and that's part of the powers that you can basically maintain a reproducible workflow in Python, where you take data from input to reporting, all with Python code. A big question is, how did we get here? So this was mostly the work of Rich Ian in figuring out how to generate the right API for creating display tables. As it turns out, there are a lot of books on data analysis and plotting, but it's a lot harder to find books on table design. But one book in particular stood out, and this is the Census Manual of Tabular Presentation. It's a pretty old book, but it contains basically tons of concepts on how to display tables and a lot of really useful recommendations on creating tables. So this was published way back in 1949, but as it turns out, it's super relevant even today. So here's an example about how to formalize the structure of a table and different parts of a table and even names you might give to them. And that's exactly what we use today. So here we have this modern take on the table display framework that powers great tables. So notice we have parts like a header with a title and subtitle. We have column labels with something called a spanner label, which is high-level columns. And then we have everything in the table body and source notes. So a lot of different pieces of the table put together here. And the hope of this graphic is just provide an easy way to get a sense for the pieces of a table. So a big question is, how do you make tables today? So if you have this raw table, the big question is, what do you do to take it from this raw input to display? You could show this table to people, but it's not the cleanest to read or to pull things out of. A really common workflow we see is Excel. You could instead copy your data out into Excel to make a nice looking table. But the big challenge here is now that you have a broken workflow, and it can be hard to reproduce. There could be quirks in Excel, right? That could be hard to capture. And so essentially your workflow has broken. With great tables, you can do everything entirely in Python. So you can have a nice reproducible Python workflow from beginning to end. All right, so to recap, Great Tables is a package focused purely on displaying tables. It's not the only approach you can use out there in Python, but we've tried to make it comprehensive. We develop it actively, and we've tried to really capture a really wide range of table problems out there. All right, so this workshop is to help you learn the process and design behind making presentation quality tables. So in this first part, I'm going to talk a bit about structure, formatting, and styling. So to go through, we're going to use this example table that we'll call the coffee table, and we're going to walk through its different pieces. So this table is mostly made of 3 pieces: structure, format, and style. And the structure pieces are pieces like the title, these column spanners, which go over our column labels, and then cleaning up the column labels themselves. For format, we have things like formatting currency values, for example, to put a $ and commas in the right place, and percentages. So notice the percentages here are whole values. So we just clean them up a little bit for presentation. All right, and the last piece is styling. Notice that we've filled the color for some of these rows. So all the revenue columns are Alice Blue, and all the profit columns are Papaya Whip. The other thing we did is we bolded the text on the bottom row so that it's a little bit easier to see that it's totaling everything, and it's a little bit different from the other rows of the table. So that's the basics of structuring, formatting, and styling. So let's talk a little bit about setup, because there are a couple pieces before we go into the code used to create tables like that. There's a couple pieces to get out of the way. So the first is Great Tables works really well with polars. And if you've never used polars is a data frame library for Python that's really taking off and has a lot of really nice, a really good API design that makes it easy to work with. Great Tables also works with pandas, but we'll use polars for all our examples in our code. And one thing you need to know is that polars has a neat concept called selectors. These make it easy to select columns of data using a really convenient syntax. So here we import polar selectors, and we can say something like starts with revenue, and that will select all the revenue columns of our data. This will be really useful because we'll use this a lot in Great Tables to, for example, put labels over columns or to grab columns to format in our table. So with that out of the way, I'm going to go into the basics of structuring tables. So what we're going to do is we're going to use this example table from Great Tables called Exhibl to show off all the pieces that I walked through before, the structuring, formatting, and styling. So to get this table, we import exibl from Great Tables, and this class GT, which is the class that powers all of the Great Tables fun. All right, so this is when we call GT over exibl, we just get this really basic table with really simple formatting to start out. All right, so let's go through first making row labels. So we have these row names in this column called row. And what we can do is we can use the simple argument row name call to sort of set the row on its own. So this is called the stub. And this sort of just creates a divide between the rows and the table. This is useful for adding a little bit of emphasis to row names. All right, so that's a really simple activity. Another one is that we can make row groups. So we have this group column right here, and we can do that simply by adding another argument, group name call, with the column name for our groups. And then notice that that will create these sort of horizontal rows that mark each group. So now our groups are sort of marked from each other. And this makes it really easy to sort of group rows and split them up so it's easy to see which rows belong together. So just to compare the table we started with and the one with a stub and row groups, notice the basic GT table is on the left and the sort of gussied up one we made is on the right with row groups and a stub. So the next thing you might want to do is add a title to your table. So to add a title, what we'll do is we'll just use this really simple tab header method with the title argument. So notice we've added the title table title right here. So pretty easy. You can also add subtitles by adding the subtitle argument to tab header. So pretty quick, but lets you explain your data a little bit more. So next up, we're going to add spanners, which are rows above our column labels. So to do this, we'll use the tab spanner method. So our key here is we'll pass it two arguments. So we're going to pass it the columns argument, which is the columns we want to put a label above, and then a label argument, which is the label itself. So notice we put the label of spanner above date, time, and date time, and there it is in the data, just right above our column labels. The next method is calls label. So what calls label does is it renames our columns. And this is really nice because in the data, column names often have underscores. They're often all lowercase. So this is a chance to clean up the names. So that's the gist of using things like tab header, tab spanner, and calls label to clean things up. Okay, so in the last section on structure, we looked at creating a stub with row names, creating groupings of rows, and then adding a simple title with tab header, column labels with calls label, and then we use tab spanner to add high-level labels over our columns. In this next section, we're going to go through the basics of formatting, so how to clean up the values of the data themselves. And the thing to know is there's a ton of formatting methods in Great Tables, so we've really bent over backwards to try to accommodate tons of situations. And if you think about it, when people copy their data into Excel, they're using tons of formatters in Excel to format dates and percentages and things like that. So we've tried to really bring that like essence of Excel formatting into Great Tables. So they all start with FMT for format, and there's quite a few around like numbers, integers, currencies, and then a lot of date related ones as well. So there's a huge variety of methods available. Okay, so we're going to go through two of them. The first one's format currency. So this is to format monetary values. So we'll start with this exibl table again, just to have a base to work from. And then what we're going to do is we're going to format this currency column here. So notice that it doesn't have dollar signs, and it has 3 decimals in a lot of places, which might not be what we want to represent. Okay. So to do that, we're just going to use the format currency method and pass it the currency column. And what it's going to do is it's going to put a dollar sign in front of currency, and just use the 2 decimal places. Since by default it formats for USD, US currency, but you can also set it to other ones. And just to show you, this is the before and after, so notice the $ and fewer decimals here. So the next formatter I'm going to look at is format %, and this is to format data as percentages. So right now we have this value column. Sorry, we're going to create this data to show off format percentage, since it's a little hard to show off in Exhibit, but these kinds of problems show up a lot. So in this new data we're creating, notice we have these values here that we might want to format as percentages. So what we do is we just call the format % method on this value column, and what we get back is the percentage sign after, and notice the decimals are shifted. It basically takes like the first 2 decimal places as percentages. So just to show you a little bit closer, notice 0.02 is rendered as 2% here. So pretty simple, but makes a big difference when you're doing a lot of reporting. So we looked at formatting with 2 methods. Format currency, which lets you say add a $ and clean up the decimals of a currency value, and format %, which lets you render percentages a little bit nicer. So with a percentage sign afterwards and treating the decimals like percentages, which is really common. So with structure and formatting out of the way, we're going to go through styling the table with a method called tab style. So tab style is a little bit more complicated than the other things we looked at, but it's not too much more difficult. It just involves a couple pieces for customizing what we want to style and how. So the key is tab style takes 2 arguments, style and locations. And so we use helper functions from Great Tables to specify these 2 pieces. And the key is that style is like the what and locations is like the where. So what kind of styling are we going to use? Are we going to color the text? Are we going to fill the background? And location is where should we do that in the data? So here's a few examples. So for styling, you can either fill the background, you can change the text, or you can modify borders. And for location, the most common one is loc body, which says somewhere in the body of the table we want to change something. But we have others for targeting all the parts of the table now that you can apply styles to. So for these examples, we're going to import the style and loc submodules, and those contain the pieces we need for using tab style. All right, so to go back to this simple table example, we're going to use the tab style method. And what we're doing here is we're going to fill the number column to be light blue. And the way we do that is we use style.fill with color equals light blue as the what. So we pass that to style. And then for locations, we use loc.body. And then notice that loc body lets us specify the exact column to apply the style to. So in loc body, we specify num to say we're coloring the number column or the num column. So that's the gist of tab style. And tab style is really neat. It can do a ton of stuff with text. It can do a ton of stuff with locating different parts of the tables. And we find that this is one of the pieces that people ask about most because it lets you customize the table and really do a lot of emphasizing and fitting for your use case. So we went through structuring, formatting, and styling. There's just 3 last things that aren't so much Great Tables concepts as things we think are super exciting that we just wanted to emphasize. So these things are nanoplots, images, and dealing with missing values. After we apply these things, we get this neat version of the table. So for nanoplots, we can add tiny bar charts to a column. For format image, we can add icons really easily or tiny images. And for submissing, it's really nice for hiding missing values. So here we had a none that I think showed up as NA. With submissing, you're able to hide values like that. Notice like these are formatters, but we also find that they're so exciting, we just wanted to highlight them here. Okay, so we went through the basics of structuring, formatting, and styling. We showed you some of the things we think are neatest, like nanoplots and images. Now's a chance to try it out. So we're going to code along to create the coffee table that we walk through so you can see it built end to end and get a feel for great tables in action. All right, thanks for watching, and we'll go to the code along.
So basically the repo for the coffee sales data, it comes from right here, github.com, mhl/coffee-sales-data. Okay, that's where the data actually it originates from. And the great thing is we have an example notebook. We have another README right here. Some really useful pieces for this. But importantly, this shows like what the table looks like right here, which is a table that has 2 sets of columns, amount % for revenue and profit. It has some visualization of the monthly sales for the sales of coffee equipment. It shows the products both in terms of icon form and also in name. And the bottom shows a total row. So it shows the total sales of all types of equipment throughout the year.
Yeah, cool. And which is just one note too, if I understand it's sales data for like a fictitious coffee shop over the course of a year.
Exactly. Not a real coffee shop at all. We don't have that kind of data.
Not yet.
No.
Yeah.
One day. We're talking to those coffee shop owners, but they won't budge. They won't give us the data. And I suppose this will be linked in the notes for the video as well. But yeah, essentially this is all the materials. If you clone this, you'll have everything. Code along was right here. Pi 01 coffee table, QMD. QMD is our Quarto documents. You may or may not Quarto, and that's totally cool. If you do not like that, we have IPyMB files here as well. And I believe GitHub is a nice renderer for IPyMB files. So here they are as well. Yeah, lots of ways to get tabling with great tables in these exercise files. You're seeing my code inside of VS Code. I have it right here. I'm just going to code along. A lot of stuff is blank, so I'm going to type stuff in as we move along. First thing we got to do, and this is a Quarto document, just so you know, I'm going to run Quarto cells here, and we're going to see the results in this display over here on the side. So the first thing we have to do is, of course, import. We're going to import polars, and then also the polar selectors, and also great tables. From that, we're going to import GT. That's like the entry point for the API. And then look and style. We're going to use that a little bit later, but that's going to be for styling the table. So the first thing we're going to do is import a JSON file we have as part of the exercise files here. We're going to use something from polars, data frame deserialize. It's a little bit eccentric, but it just sort of makes it a little bit easier to get the data in the right form initially. So I'm going to run that right now. And we see right here on the side, we have a table. It's nothing like a display table we want to show other people, but it is a table, and it has all the information we need to make a great table. So good stuff so far. We're seeing it right here. So let's get this data, coffee sales data, into great tables. So what we're going to do for the rest of this code along is we're going to assign it to separate objects and then sort of build, as we go with these separate objects and see the result. Okay, so we're going to use coffee sales, which is our variable, which has a table. Introduce that to the GT class. We're going to run that cell. And here we are. I'm just going to scroll back so we can see the headings of this table, this very large table. This is an HTML table. It's going to look much nicer once we basically use the different methods inside of great tables. So the first thing we want to do is some structural stuff. We want to add a title to the table and explain what's in this table. So I'm going to uncomment these little bits right here. And the method we need for this is tab header. Great, we sort of see some autocomplete stuff. We see what we need. It looks like here we need title and or subtitle. In this case, we're just going to use title. And the title I want in this one is just going to be coffee equipment sales for 2023. So like fake sales, really. I'm going to run this cell with my shortcut here. Great. It updated the table, but we can't see it until we scroll to the top. I'm just going to verify that the title is entered, and it is right here. Coffee equipment sales for 2023. Awesome stuff. So the next thing we want to do, because we're off to a great start now, we want to do things like add more structure to the table. So my next little instruction here, my little brief, is to group numerical columns with a spanner. One grouping should be for revenue columns, so revenue dollars, revenue %. Another should be for profit columns, so these two columns right here on the side. So I'm going to do that in a similar way. Uncomment this code here, this commented code. And for this, I'm going to use two invocations of tab spanner. Okay, so tab spanner, it takes in two important arguments, the label and some sort of column selection. Okay, so the first thing I'm going to do is, use tab spanner, and the label, I'm going to start with the revenue columns. So I'm going to call this label revenue. And the next part is columns. It needs to know which columns to group under the spanner. In this case, I'm going to use CS, which is actually column selectors from pollers. We just imported that as CS. So it's going to be CS starts with, I'm going to autocomplete that. And in this case, it's going to be revenue, lowercase. Okay, so that'll get the columns that begin with revenue. Great. I'm not going to run this just yet. I'm actually just going to tidy this up a little bit, put it on one line. Go to the next line, second instance of tab spanner. The label in this case will be profit with capital P. And the columns in this case will be starting with profit. So columns will equal CS starts with profit. Okay, so now I'm going to run this. Great. So this updated. We're at the bottom of the table, so you have to scroll up to see the effect. But the effect is that we have revenue above the revenue columns and the spanner label profit above the profit dealing columns.
Nice. And Rich, do you mind saying a little bit about why you would use tab spanner like that?
Yeah, it's great for grouping, so people can just see right away, oh yeah, this part of the table just deals with revenue. So whatever columns deals with that. This part is focused on profit. We can just get a quick sort of like, we don't have to like parse like the names of like the columns, and also to avoid some redundancy. We can imagine later on, we can have revenue, and we can have we don't have to repeat revenue here. We can just say dollar amount or percentage, right?
Yeah. Cool.
So it's kind of like a mapping, which is kind of convenient. And we see it in tables all the time, so it's actually quite natural. And, like people know how to parse that.
Oh, nice.
Yeah, super useful. So we got these. So these look great, these spanner labels. The problem is our column labels, they don't look too incredibly great now. They're super redundant also. So we're going to fix those with a different method. We're going to take GTTable3. And in this case, we're going to use calls label. That allows you to relabel the columns, the column labels. Right now, they're just taken from like the column names in the original data set. That's usually never what you want. You usually want to relabel them. So in this case, we have to do things like use revenue dollars. We have to give the column names, and then the label that we want. So amount in this case. So we'll do the same thing with revenue percent, like that, and just use percent here. I'm going to copy these both because we're going to do the same thing for the profit columns. So in this case, I'm just going to use profit here, and then profit percent, and then this will still be amount and percent. As a final tweak, monthly sales, which is on the far right, we're going to change that to be capitalized and removing the underscore. So monthly sales will be this. And one more, I think product will just become basically like nothing, like a blank cell. Let's sort of like no label at all. Actually, no, we'll leave it as it is. And we'll come back to it if we need to. But I think this is going to be great. So if I run the cell, scroll to the top, takes a while, we'll get there. There we go. And now we have like amount percent, monthly sales. Okay. Still not looking great because we're not really finished yet. We have to deal with a few more things. And a lot of it has to do with formatting.
I wonder if we drop the monthly sales column, if that'll help with visualizing the table.
Yeah.
If you drop it from the...
Like just from like right... Oh, like calls hide. Yes, you could do that. Instead of dropping it from the data, we can do it this way, if that's what you're thinking.
Yeah.
And we do columns. It's like a temporary dropping.
You just try to...
Yeah, and then the columns will be monthly sales. Now if we run this again, we see, yes, we could parse this a little bit better because we don't have this giant list column sort of getting in the way. Yeah, it looks kind of nice this way. And this could be a temporary thing. We don't have to use this in the end.
Yeah, I wonder if it'd be useful too to say a bit about, so I saw you typed in monthly sales in calls hide.
Yeah.
Do you want to say a little bit about how you know the name of the column, like monthly underscore sales?
Yeah, so this is like a little issue. You always have to refer to the column names themselves. And so you might have to scroll back to remember what they are. And if you're changing the labels, like it's going to be a little bit hard. You can't really iterate that easily because you've lost the column names here in your view of the table. So there's a bit of scrolling back to, or looking at the original data frame to see what the actual column names are. That's what you're driving at, right? Like,
Yeah.
basically, it's kind of like you have to be cognizant, because if you flip it the other way around and like the label becomes a new column name, that is actually confusing. You're sort of like your state changes, and really, which one a nice anchor to, because the columns are so fundamental to changing, sort of targeting where we want the changes.
So just to be sure, the monthly underscore sales is the name in the original data. So even though you change the name to like this friendly one, which is like monthly space sales, you just use the original data name to...
Exactly, yeah. Whenever you're referencing a column, it's always the original name. And this is kind of like a label for that name. You can think of it that way. And it just so happens that the column name becomes the label initially, but that can be changed here. So this is like relabeling the data, like the column labels. Okay, so we'll move on, and we'll do a thing now where we change these values, which are not really friendly for amounts, into currency values, because we're talking about coffee equipment sales for 2023. So in this case, and I'm also going to rerun this as well to put that back, because we'll need that later, that column again. So in this case, we'll want to use a method called format currency. Okay, and in this case, we do want to target all the amounts or all the columns that have dollars in the name. We can't see here, but we know that it ends with dollars. So in this case, we'll use columns, because that's like what it needs initially. And we'll use CS, ends with, in this case, dollars. Okay. And also, we'll do another thing with this. There's lots of options inside each of these methods for formatting. But in this case, we don't need the cents amount. Like, it'll by default include cents along with dollars. So we'll use an option called use subunits. It's initially true, like by default, but let's set it to false. Okay, and let's take a look at the result of that. Okay, so notwithstanding this stuff, which is on the side, we can at least see that these columns here have like dollar signs, and there's no cents. There's no decimal with 2 zeros past that.
I wonder if we need to hide that column, because it's a bit hard to see the result.
We can totally hide that, yeah.
And then maybe we can comment out like at the very end, or...
Yeah, sounds good. Calls hide. And then it'll be columns and monthly sales. Yes, I'm gonna run that. Great, and I'll rerun this. Yeah, and totally, it's a little easier to read. It's all basically on one page. Okay, so we dealt with the amount columns, which were dollars amounts. Now we're going to deal with the percent amounts, which are right now fractional values. We can totally change that. We've got a method that deals exactly with percentages, and that is called format percent. And again, we can target columns.
Just to be sure, like, because we can't see the column names here, like, how would you check them to know the column?
It's going to be a bit of a scroll back, yeah. So we can definitely go to calls label, or we can entirely omit this calls label till the very end.
Yeah. Is that something you do often, like leave calls label to the end, or how do you usually?
I usually do that, yeah. It's a good strategy, but you wouldn't know that until you do it the wrong way first, like I did. Which is not necessarily the wrong way, but it gets a bit unwieldy when you have lots and lots of columns. It necessitates a scroll back to find out what they are.
Yeah. We could also put the data into the console, like on the right-hand side, like where it says press enter to execute, you could...
oh yeah, that's right. So you could just do, like what was the name of the coffee sales?
I might show it.
And then execute, which I've never seen to be able to do properly. Yeah, and there they are again. This is a nice handy way of doing it, I agree.
Nice, so you're targeting dollars, is that? Oh, you're targeting...
PCT, yeah, exactly, these two columns.
Nice.
So this is definitely another case of using ends with, because they're named in a systematic way. We do ends with PCT. I think in this case, we want to have no decimal places showing, just like the dollars deal. So we'll use decimals. By default is 2, but in this case I want 0. Okay, so I'll run that. And again, you can choose whether you want fractional percentages, but I think in this case, you won't even see anything there. So this is quite nice. Good. Okay, and now we're going to do some styling. This table looks good, but it could look even better with a little bit of styling applied. So in this case, what we have here as a design brief is to use an Alice blue background for the columns that pertain to revenue. Okay, so basically these 2 columns here under this pattern. So we can totally do that. We can use tab style for that operation. So tab style. And this method has 2 different arguments, style and locations. So I'll make a note of this because at the beginning we had to import, I'm going to scroll back, loc and style. These 2 classes are specifically needed for tab style. If you don't have this imported, you won't be able to use tab style. So the key thing is to import those if you're using styles, and then to use them in the 2 different arguments. Okay, so in this case, what we'll do is we'll start with style, and that'll be equal to, so this is the thing we imported, style. The particular thing inside of style we want to use is fill in this case. So it pops up at the top. There's borders, fill, and text. In this case, we want fill because we want to change the fill color of these cells. Okay, and these have different arguments. The only argument here is actually color, and we're going to use the color Alice blue. So it recognizes things like color names, like CSS color names, and they can all be written in lowercase like this. Okay, second argument is locations. In this case, you need to use the loc class, and within that, you'll see there's one thing, body, here. So within that, there is 2 arguments, columns and rows. In this case, we want to fill the entire column, of revenue, like both revenue columns, with that style. So in this case, it'll be columns, and here again, we can use CS starts with, and we're going to target columns that start with revenue. Okay, so I'm going to run this, and we do see that we got the result we wanted. We got Alice blue filling the body cells of the revenue columns with the Alice blue color. Great. So now we're going to do the exact same thing, or pretty much the same thing, with a different color for profit. And so what I'll do there is I'll comment this, and I'm just going to copy this for the sake of expediency and just change a few things. Okay. In this case, we're still using style fill because we're just filling columns with a color. In this case, it's papaya whip. Great. And this time it's not things that start with revenue. It's going to be things that start with profit.
Do you mind showing us how you knew that? Like if you had to show people.
Yeah. Again, I would look at coffee sales. Sorry, I'm just going to run this data frame. And again, this is like my guide right here. So I just know intuitively that these 2 columns, because the order hasn't changed, the revenue ones, and then I know that the next 2 columns are profit, beginning with profit. Yeah.
Yeah, nice.
And then multi-sales is something we hid. So yeah. The thing is I had in my mind, but if you needed to like refer something, I would definitely just look at the original data frame.
Yeah. Yeah, it's helpful to see it, I think, because the names, I feel like sometimes it's tricky keeping track of all the names.
You lose that stuff here. Yeah. And this is the last thing you see. You have to scroll back quite a bit if you even have it in your interactive console. So yeah, totally. I would just refer back. Okay. So I'm going to run that right here. Oh, it did not seem to take. There's probably a reason for that. Let's take a look here. Papaya whip. Look, body.
Is papaya misspelled? Is that?
I think it is. Yeah. There we are. Okay.
You did it.
I love the teamwork. Teamwork. Oh my God. That's what does it. There we are. Now we got it. So rule of thumb is always know how to spell papaya whip or any color that you want to use. So there we are. That looks great so far. Okay, so here's another thing. We have a row, which is pretty much like a summary row. We have a total and total dollar and percentage amounts. Great. What we want to do is make that prominent by making the text bold in the bottom row. So let's do that. It's going to be a case, again, of using tab style. But it's going to be a little bit tricky because we have to use an expression. If you know polars really well, maybe this won't be difficult, but it might be something that trips you up. So let's go through it slowly. So the first thing is style. We're going to fill in that argument with the style we need. In this case, it's not style fill. It's going to be style text. And there's many options in here. I'm going to shortcut it by just saying the option we want is weight. In this case, the weight value will be bold. Great. So that's taken care of. And now how to target the entire bottom row. Okay, a little bit tricky. So we're going to start with the argument name locations, just so you know that is it. Loc body. In this case, we want to use the rows argument. And we want to use PL call product. So in the product column, we want to target the row that has total in it. I believe it's like this. Okay, let's unpack this just a little bit. So this is the product column. We can still see the column name, which is great. But we have this row which has the text total. Okay, so what this returns, this expression, is the row number, right? That's going to be applied to all columns because by default, all columns are chosen. Okay, so here we go. I'm going to run this. Great, so that worked. So the tricky part here is remembering PL call and putting the column that's focused on inside that, and then like making that equivalent to total. Great, tough stuff. Well, not that tough. You basically, what I have to do sometimes is look at the polars docs, and I often look there because it's not truly second nature, at least to me. Okay, so a few more things we want to do is add a column of bar plots to the monthly revenue column. We axed that earlier on, but we can get it back. We just have to remove and rerun some stuff. So I'm gonna do that right now because we've shown that this works and it's a little easier to see. Let's remove that calls hide statement, which is right here. It's served its purpose. Great. And now let's go down to the part that we want to modify. Let's run all the stuff above first. Okay, great. So the thing we're going to focus on is this list column right here. Basically, this contains data for plots right here. We call them nanoplots, monthly sales. So how to get that in the table?
And a note might be, if you haven't heard about list columns, they're kind of a funny piece of data. Do you want to say a little bit about what a list column is? It's kind of a funky...
Yeah, as far as I understand them, I'm not going to type. As far as I understand them, they just contain lists within each cell of the column. And I believe that they contain lists all the way down. Or otherwise, they're not valid. I'm not sure what the rules are for like, how I think they contain various size lists. I believe that's how it works. But the key thing is that there's lists in each cell within a column.
Yeah.
A list column.
Yeah, I think so. It's like where normally you just have a single number. You can have a list or array of numbers, and it can be any like length. So it could have like 100 numbers, right? A list of 100 numbers on a single row.
Yeah.
They've all got to kind of be the same type.
Yeah.
But great tables can do kind of magical things.
Yeah, which is great because a nanoplot here, in this case at least, is a one-dimensional plot showing like each point as like a y value across like an even sort of like set of x values. Better to see it than to explain it fully. So I'm just going to use the method called format nanoplot. And the first thing we need is columns. So we're going to focus on that column, which is monthly sales, because that is the list column, which contains the data. Great. And in this case, like the default is like a line plot, where it just shows a line connected with basically a bunch of data points connected by a line. We don't really want that in this case. We want the different plot type, which is a bar plot. So that's one of the keywords here, plot type bar. Okay, we're going to hope for the best, run that. And I do have to scroll because like space is limited here. I try to make this pretty large for the purpose of the video, but necessitates a little bit of scrolling. We can see here if you hover over the different bars of the nanoplot, we see the actual values. So which is really, really cool right there. And it does its best to sort of make these values kind of small. We see here things like 521, 496, but for large values, we have values like 4.74K. So it tries its best to condense the values so they actually fit in this small plot space because it's limited space. So really super cool, I would say.
Incredible.
Thank you. That's my thinking. Yeah.
Okay. Plots just blow my mind every time.
And they're fun. You can just hover over it. It's like, oh my God.
Right.
Like it's got a lot of dense information here. It's got like the trends that it's showing. It's also showing the values should you need them. 2 for 1 deal.
Yeah, it might be worth noting like anything interesting in there, or like what you might find in the nanoplots.
Yeah. For that, you could just parse like right here, the different options, which of course is terse.
Oh, I mean like in the nanoplots that you just printed out, is there anything interesting?
Oh, yeah. So we can see from the actual data. Yeah, the coffee sales. Yeah. I'm seeing right away that like some things are peaking in the summer, some things more than others. Like cold brew, it's very obviously a summer thing. In the winter, nobody's caring about cold brew.
Right.
Like these colder months, like, I guess these coffee sales occur somewhere, with 4 seasons maybe. But yeah, we're sort of seeing that right there. And we're also seeing, what else do we see here? Espresso machine. It's very much a few months at a time. Looks like Christmas. It does pretty well. I don't know what this would be, Valentine's Day? No, it's not even close. I don't know. Summertime?
Summer sale? I don't know.
It's counterintuitive, but it's showing something. And like, I'm not going to question these fake sales.
Yeah. And if it isn't, we also fabricated this data. So if you're a coffee salesperson, please don't fight us.
Yeah. It's a pretty good data set. It looks very convincing to me. Yeah.
I'm convinced. Yeah.
Awesome. So that's what we have here. And you may have noticed a long time ago, like when we started this, we have this column called icon with very obviously file names for images. We're using that now. So we can add images to the icon column. The input for an image is the file name itself. And we can use a method called format image. And the thing you got to do there is just point towards where the images really live on disk. Oh, not images, but format image. You got to get the spelling correct for these things. Okay, and like many of these formatters, the first argument is columns because we want to tell grade tables what column to focus on. So in this case, it would be icon. Great, that's part 1 of the puzzle. The second piece is essentially the path to the images.
Do you mind showing people where the images are? Like, how do you know where
Certainly.
the images are?
Yeah, this requires a bit of pre-planning from the user. But we have in our exercise files an image directory, just in like the root of like the project. And here they all are. So they're within image. And these names do match these names. If they don't, you'll find out pretty quickly. So this, again, involves a little bit of pre-planning, some being systematic with your file names. But once you do this, once you have them lined up in terms of file name and the actual name used in the table, you do get the images. Mm-hmm. And it's really kind of cool.
When you're typing path, can you map kind of just how what you're looking at?
Yeah, certainly. Okay, so right now, coffee table, it is encoded along right here. It's in a subdirectory inside the root. Like, it's in a subdirectory. So we have this right here. So we have to go back into the root and then go to image, right? So in this interactive way I'm using like my grade tables demonstration, I have to do this and then provide the directory image right here. And I think we should do this as well. Maybe you don't have to, but I think you gotta do that. Because what happens is this sort of like combines with this to give you paths, relative paths. Is that?
Yeah, it seems super helpful.
I think it's pretty good. Yeah, the key thing is just to use directory navigation. Sometimes you may not get it right, but you have to realize where you are and where you want to go in terms of the path. And it's relative to the file. Okay, I'm going to run this and see if it works. Whew, it does work. That's good. So we see these cool images. Like, these are fantastic little icons for each of these things. Like a French press, that's in there. Pour over, it's in there. AeroPress even, that's in there.
If it exists, we got it,
Yes, it's amazing to have these little icons. Like, what a world we live in to have these. We even have do you know how to pronounce this, Michael?
No.
I do not. Okay, this is for another day. You heard it before, but it's so forgettable.
Someone told me, but I can't remember. Yeah.
Yeah, I think it's never what you think it is in this case, but okay. I'm pretty sure this is Chemex.
It might be worth noting too, like if you, in your console, if you do percent PWD on the bottom right,
Oh yeah, yeah, yeah.
that'll tell you where you are.
Oh, I love these
That's
magic
kind of the
commands.
like last, that's like the
Oh yeah,
indicator of like,
code along. Yes, and it gives me the full absolute path.
so then
And of
you
course,
like go back one to
go back one into here, and then like into image. Yeah,
Mhm.
I'm not sure about this. I think this is needed as a connector. Let me just run it without. Oh, okay. It probably like in the pathing thing, it eliminates double. It adds it in, or eliminates a double slash. Okay,
Yeah, nice.
very good to know. Very good to know. Okay, the final thing. We're almost done here. We have these none values here in the table. We don't really want those. We can call those missing values, none values, whatever. We can get rid of them though. We can turn them into blank cells. We use the method called sub missing. Okay. So what it does is allows you to select the columns. By default, it selects all the columns. So it just sweeps across. And then the thing you want to supply is the missing text. I'm going to type that in right now. Okay. You can supply a bit of text. Another thing you can do is supply an empty string. That just sort of eliminates the text, that is. So let's actually run that. Okay, so now it's gone. If I go across here, we don't have none here on the left or the right. Let me expand this out so you can see the table a little bit better. There we go. It's a big table, I suppose. But it's nice. What do you think, Michael? Good table, right?
Yeah, I
Nice
love
table.
I feel like column spanners for some reason are like my favorite thing, but I can't explain why. Just having the label.
I love it too. Now, there's one thing I could have changed previously, and that was with calls label. I could have removed icon entirely, because like that is probably self-explanatory. You could just like use an empty string there as well. And product, I probably would have capitalized or written it differently. But other than that, this is a pretty polished table. It's got these nanoplots, it's got formatted values, it's got some style, it's got the structure, the title.
We're already. I feel like we're all ready to open our coffee shop. You know, with great tables,
Exactly.
great coffee shop.
Yeah, this is wonderful. Yeah, so this is the code along for the coffee table. Hope you enjoyed it. Hope my typing wasn't too incredibly slow and painful. But yeah.
I learned a lot. You know.
Thank you. Thank you.